Hey everybody. So my title up here is Operations Database Engineer. That's fancy for they let me do systems administration stuff as well. So a little bit more than just the database side of things. I've got a couple of links on here. There's everything we're talking about today is completely open sourced. So there's our company web page on GitHub and the link to DBdeployer, which is the tool I'm going to be talking about today. Then I do have some sample database stuff on my own personal GitHub thing that we're going to be going through those particular things in this demonstration. So you're welcome to pull those down if you look at it again later. And then we do have a company tech blog that we put all kinds of stuff as we're open sourcing things or doing interesting things. So that is scriptscribe.org. I do have some stickers if anybody wants those afterwards, so feel free to come up and ask for those. I'm going to give a couple of quick definitions. I think a lot of people will probably already know what these are, but I'm going to be using them and don't want people to be lost. So in the database realm, we talk about CRUD apps, create, read, update, and delete. There's DDL, which is data definition language. That's basically standing up the structure of the database. And then there's data manipulation language, which is basically altering things inside of that structure. And then I think everybody's familiar with service level agreement. Is there a question back there? Okay. So some common database problems. I've seen these across all of the environments that I've worked over the years. And there's different ways to combat individual ones, but to just kind of run through some of them. Typically, you're always going to have lots of environments. You might have 10 different test environments for your developers, integration environments with customers, alpha, beta, sandbox, UAT, production. And all of these typically end up in different deployment schedules or states. Two customers that are integrating with a particular piece of software, one's going to be on one code base, another on another. And you have to be able to track what's going on with those databases and know what you've got. So that can be difficult the more and more environments that you have. Database administrators also need early visibility into changes to kind of audit them for normalization, architecture, impact, things of those natures. So you don't want developers coming in saying, hey, this needs to go to prod, and you realize that it's going to be a huge performance hit. So there's normally a recommendation to try and engage the DBAs earlier in the process. When you look at deploying things, you never want, from a security perspective, something to have more permission than what it needs. So if your application only needs CRUD application access, it shouldn't be able to create tables, drop tables, do things of that nature. Another thing, and this is always something that's wanted, but rarely have I seen it implemented in a good way. Developers love to be able to just stand up a local copy of the database and do everything that they need. And having that tiny database, unless you put practice in from the early onset, you typically don't have the ability to stand up that minimalistic data set that you need to be able to run an application. A lot of times things get stood up in prod, it kind of grows that way, and then you realize, oh wow, I've got a 40 gigabyte, terabyte, whatever database size you grow to that gets very difficult to port around, work with, and you can have sensitive data that prevents you from being able to just copy things from one environment to another. Let's see here. Another thing that you can come up with is differences in seed data. Production might point to paypal.com where test points to sandbox.paypal.com or things like that. You're going to have differences in your environments that are actually baked in, they're there intentionally, and you still have to be able to manage those differences. There's a variety of replication strategies out there. Sometimes it's something as simple as native replication. Sometimes it's trigger-based replication. Sometimes it's I need to ETL this data around. And as you deal with those different types of things, sometimes you need to stage database deployments through your analytics boxes first so that things are going to be able to flow correctly. So you've got to always know what your upstream and downstream dependencies are and have some way of being able to deploy changes in a way that's not going to be breaking things. And then I'm sure all of us are familiar with change control. It's a popular topic in a lot of different conversations. So you need to be able to manage your database deployments the same way that you do everything else. So to talk a little bit more about production change requirements, these are the ways that I typically see. Some have more, some have less company-wise as far as how they look at their change control requirements. But there's typically about 4 ways that it's acceptable to change data within your database. One is the application directly. You're always going to have application users logging in, doing things. Another's an administrative interface. Maybe your call center has a different interface or something of that nature to be able to log in and change data, but it's still gone through a development cycle and it's seen that peer review, been through a deployment process. A peer-reviewed change deployed through a known and tested process. That could be maybe a stored procedure that certain people are authorized to be able to connect to, or in the case of what we built today, this is the way that we use DBdeployer. Everything gets pushed up into it. We've got a review process, a test process, and things wrapped around that in the way that we utilize it. And then lastly, directly through a change control, where it's typically a more manual process. So again, there could be more, could be less, but those are some of the change control requirements that I'm pretty familiar with and what this tool is designed to kind of work within. There are a lot of tools out there that can manage the various ways to deploy database migrations. Ruby Rails has its own rake migrations, things of that nature. There's dbmaintain, good product. Delta SQL, good product. There's a handful of them. These are the three that I looked the most closely at. And they all had some shortcomings, be it, they did a great job at managing the DDL, but if something broke in prod, we fix the application, but we've got fallout where we have to fix data from that. That one-time data fix might not flow well through a product, or maybe it doesn't do the seed data that's different between environments, things of that nature. So after evaluating some of the tools that were out there, we decided to go ahead and build our own. So actually, let me talk a little bit more about Rails migrations in particular. We're a Rails shop. We do tons of stuff with it, and that was one of the biggest things that we evaluated. So one of the things that Rails does is it intentionally builds things to use as generic of SQL as possible. It tries to work with everything. It's abstracted everything out, and it wants to treat SQL Server the same way it treats SQLite, the same way it treats MySQL, the same way it treats Postgres. And that has all kinds of issues. If you're not utilizing the feature sets of your database, you're probably doing something wrong in the first place, in my opinion. You need to build towards your strengths. Rails migrations can also reduce visibility of what the SQL will actually be doing when it's deployed. If I've got a 10 gigabyte table and somebody wants to add a new column and set a default value, Rails is going to say, sure, I can do that. And it's going to go through and it's going to lock that table while it adds that new column and updates every single row throughout that process. So you might end up with a 15-minute downtime because that table was locked. Whereas if I can see that in SQL, I can say, you know what, let's do this a different way. And it can be a non-impacting process that's still a daytime deploy that fits well within our continuous integration, continuous deployment schedule. Migrations can be difficult to stage if they have downstream dependencies. If I'm managing that through Rails migrations, how does that affect my analytics database? How do I keep that up to date? What changes are there? How do I link that type of stuff? I'm not saying it can't be done, but it can be very difficult. And then if more than one app uses the same database, who manages the Rails migrations? Do we have a parent app that all the database stuff goes through this, and we have to install that app to be able to get stuff to work through another app? Or do we want it to be, maybe we abstract it out to the database layer, so there's just a Rails database migration app that you have to run before you do things? Again, it can be achieved, but still a difficult process to get through, poses a handful of problems. So what is DBdeployer? It is a command line utility. Yay. Everybody loves the command line, at least at places like this, I would think. Basically, it's going to go through and execute the native binaries that are in use. One of the things I didn't want, being a Ruby shop with a whole bunch of stuff on SQL Server, we occasionally see issues in drivers and things like that as we're going between open source, closed source, run into some issues. So I didn't want anything that was going through a driver layer or anything like that. Let's use SQL command directly. Let's use pSQL directly. Let's use MySQL directly. So it was built to actually do that. It tracks database deployments in its own database. So every server is going to have its own deployments database, tracks everything there. We've got logging stuff in place so that we can actually track reference URLs. So that could be maybe a GitHub link to the pull request that's going to be changing data. It could be a change control ticket directly, whatever you want it to be. And then throughout the change control process as well, as people are developing, and I'll get into this a little bit more later, but as people are developing, it does have that test cycle and everything that you would expect from a change control baked into the process. One of the things that we also build into it is the one-touch button to bring a database to current. Since we know in our database what's been deployed here, and we know what's on the file system through migrations, we can calculate the difference, and then based on the order that's specified, it can bring everything to current. So you can have one button and say, hey, bring me to current. I don't care if this was, had 3 of the 17 deploys that were out there or whatever. It'll bring everything to current very simplistically and calculate what those differences are for you. It also addresses the one-off deployments to fix application data, or if you have differences in the seed data, things like that. And if you start with this product on new databases, you'll always have a tiny database because you're essentially just playing through every change you've ever had. So if your first change is creating a users table and going on and going forward, you're always going to have that ability to be able to go forward. You can still port yourself into the tool by doing dumps and things like that, and then tracking migrations forward, or you can say, you know what, it's going to be a lot of work to get to that simple tiny DB, but we can still manage everything going forward with this to make things easier to maintain. And then it also does support differences based on environments as well. In prod, I've used the black hole engine before with MySQL to write to an audit table, and then as it writes to that audit table, dev null, great, goes to the bin log, and then that bin log plays back to the operational data store server where all of those reads for that actual audit table would occur. So in all of my test environments, I don't want to stand up all this replication and everything. I'd actually have a simplistic, different structure where maybe that's not a black hole engine for my audit table and test, but in production it is. So it's going to support some of those differences. Let's see. ORMs, like I said, they can do some weird things. So once you get that actually exported out to the SQL, you're going to have a better understanding of what's going to be changing and if it needs addressed. Changes can be audited so that ETL jobs aren't going to be broken or are less likely to be broken because you're actually getting eyes on what is changing as things go through. Everything is scripted, so basically your database can now be deployed like an application. Once you know the SQL's safe, your database administrator doesn't have to be the one to push a button or manage and deploy things. And then database changes are actually managed separately from the application. We always encourage everything to be backwards compatible, and sometimes that actually, especially for daytime deploys, is going to require maybe I have to stage things into this one table, then deploy the code, and then deploy another database thing to pick that up. So depending on what kind of processing you have around that, again, all that can just play through the migrations in whatever order you'd like that to go. So you can do staged rollouts with trigger-based replication. Like I said, we do a lot of stuff with analytics, so maybe we need to update their databases in preparation, set up the ETL jobs, pause them so they're not going to run, get everything changed, change the production data, and then turn all those ETL jobs back on so it's catching all of the data flow through. DBdeployer has a reporting functionality. We haven't written and open sourced it yet, but it is on our list to do. It'd be very easy to just check the report to see if anything needs deployed. So if you're looking at SLAs and you've got Git hooks and stuff tied in to keep your repo up to date locally on whatever server you're looking at, you can say, hey, go ahead and alert me if this is more than 72 hours out of date with what master is or things of those nature. To make sure that you don't miss environments if they were turned off for test or whatever. So a lot of neat things you can do with that. And then the environment-specific data is really great to work through. So how does DBdeployer work? It's actually intentionally built very simplistically. Whenever I stand up a new database, it's a pretty straight-up process. I'm going to start with my schema. I'm going to roll through my seed data, any inserts that need done, and then I'm going to play through any changes that I have. There's also a rollback and an archive folder. I'll go through those a little bit more detail throughout the demo that I'm going to do. But essentially, from a development workflow, everything that I do is a change, period. There is nothing that isn't a change to the system. So that's the only folder developers really have to worry about. And the reason that we have some of the other folders is to kind of allow us to roll things up. If I were to get to the point where I've got 500 changes, 1,000 changes, I don't want a developer when they stand up their own local instance to have to wait to play through all of those changes. So I can baseline it, basically stand up a tiny database, throughout all of those processes, and then I can dump that and break it up into the seed data and the schema, and then I can shove everything over into the archive, and anybody who already has it checked out, they can go ahead and play through the archive and then continue to play through changes, not have to worry. Anybody who checks it out new doesn't have to play through everything because it's already in the archive and they're not going through it. So pretty simplistic structure. Rollbacks are exactly what they sound like. So this is one of the things that is both a strength and a weakness of DBdeployer. It is written in bash. That's how I achieve actually calling the binaries directly. It is broken out into functions and things like that, so it's following standard programming practices, but we do have obviously global namespace potential collisions and things like that. So we've done a lot to work around it, and it's working well for us throughout our production stack at this point. Mentioned it tracks its own deployments in its own database, and then it also is based on a alphanumeric ordering of the files and the changes, or in any of the folders. It plays through all of the folders basically. And we use version control, so we can't really use the timestamps of the files, so we build it into the naming convention of the files. So it's very dependent on the naming convention. Our particular workflow, right now we have devs, they'll create a feature branch, they'll create a pull request, and they'll tag it, hey, I want this reviewed. And that's how we get ourselves engaged early in the process. So we'll take a look at that, we'll give them feedback, they might need to change it, they might need, hey, maybe it's good to go, it's a simple change, whatever it is, and we'll go ahead and tag that and say this is good to go. Any other DBA that looks at it knows it's been reviewed, can see all of the conversation back and forth in that. If maybe you guys need to normalize this table out a little further or change this data type or whatever the case may be, you can see all of that back and forth in the conversation within GitHub. And then once it's approved, the developer is going to say, hey, I need it out on this test environment. Can you throw it out there for me? So typically, it doesn't have to be a DBA, but again, DBAs are sysadmins in our place. Database operations engineer, coming back to that. So normally it is a database administrator that'll go ahead and deploy that out to whatever test server they say, and then we'll update it and we'll say, hey, this is in test. If a DBA is not around, anybody on infrastructure can go ahead and deploy that out as well. So we try to not have any bottlenecks around that particular piece in our workflow. Once it's through test, developers, they can come back in, hey, I've tested it, it's ready to go to, maybe it's prod, maybe it's an integration environment, wherever it is next in the workflow. And again, everything's tracked within that same PR, so you've got that full history there. You see what's going on, and when they say, hey, it's tested, it's ready to go to prod, anybody on infrastructure can go ahead and say, okay, here it goes. And we can then, once it's merged to master, currently we've got scripts in place. When something hits master, it'll automatically push out to all of our test environments. And again, if a test environment's off, the next time it happens, it's going to automatically catch back up. So it's a pretty smooth workflow. We're actually looking at building a Puppet module so that that'll actually flow through the rest of our process the way that all of our applications do. So Puppet will actually be able to manage some of the database deployments to non-production environments. We may end up doing it to production too based on different types of tags. So without further ado, we'll see if the demo gods want to cooperate with me today. So hopefully everything will go smooth here. Do we have any questions before I get into a demo? Okay. All right, let's change my display to be mirrored so that I can see without craning my neck. All right, so I've got a Vagrant here, stood up locally. Again, all of the notes, these are going to be harder to read here as I flip back and forth, but all of these are in that repo, in my own personal GitHub repo. I'm going to copy these and basically paste them out, so you will get to see everything. But essentially, to install it right now, everything is based on an installer, simple shell script. So here, I'm going ahead and cding to my home directory and then doing a git clone, and we'll see if my internet continues to work while I'm up here. And if it doesn't, I have a copy of the install here as well, which it looks like that's going to hang. so internet's not going to cooperate for whatever reason. I'm just going to go ahead and copy the DBdeployer GitHub directory here to DBdeployer, which clearly doesn't work when I don't include a recursive flag. All right. So there is a DBdeployer install file that you must be root to install. Which works way better when I just copy and paste everything and it goes forward. So very simple installation. It will give you errors if anything fails. It gives you no output on a successful install. So now that I've got that installed, we use Postgres for most of our databases, so that's what I'm going to be going through in our demo today. And DBdeployer is actually heavily geared towards Postgres. It's set up for that out of the box with an install. I do have a on the actual wiki page here, I go through all of the differences if you want to use it with SQL Server, and it talks a little bit about how to extend it. So you can get to that, but I'm going to go ahead and switch user to Postgres. One of the things that we do, we didn't want to open up the security hole to say, hey, let's have administrative users connecting from other machines. By default, there's a trust relationship with Postgres users, so we do everything locally on the box as that user. Oh, yeah. So I'll go ahead and switch user right here to Postgres, and then I went ahead and changed directory to the Postgres directory. It looks like my internet is now back and working, so it was successfully able to clone my personal databases repo, so that's now cloned to the box. And then by default, everything's in userlib DBdeployer. For us, we wanted to have our checkout in a different location, so I actually did a override for our base directory where our databases are going to live into a home file for my user that I'm deploying as that gets sourced as it goes through. So DBdeployer is now installed. I have gotten everything set that I'd like to install for my own personal databases, be it company or whatever. So now I'm going to go ahead and set up my tracking database. So again, the notes section there, I don't necessarily need to increase the size of, but I'm going to go ahead and create a database deployments directory right here with just the create db command. And then this command I'm going to break up and actually show you a little bit about as we go through. There we go. So we've got DBdeployer-D. So we've already set up an override for what we want to deploy our databases from, the location. By default, the deployments database it lives in varlib DBdeployer. So I'm going to say, go ahead and, even though I specified this in my override file, there's a command line override as well. I want to deploy from this location. I want to deploy the -D of deployments, the deployments database that lives in that folder. There's a -E of Postgres, that's my environment flag, and then there's a -U. So I'm not actually going to run this yet, but I'm going to show you guys, if I go look in varlib DBdeployer, there's a folder called deployments, and inside here I've got my archive, my changes, my rollback, my schema, and my seed data folders. If I were to actually look one step further and check out, say, my schema, I'm going to see that I've got a schema file of 1000_schema.sql, and then I also have folders inside of here for MSSQL and for Postgres. And the way that DBdeployer works for its environments is actually based on an override. So it's going to look for any files that exist in that regular folder, and then if that same file name exists in a folder inside of that, it's going to override with it. So if I were to actually cat out the 1000 schema, it's an empty file. But that gets overridden when I specify my environment with Postgres to actually have a table here that's going to build everything out. So that's how it accomplishes its environment override. So if I go ahead and paste back my command here, it goes ahead and runs everything that it needs to get my deployments database up to date. Everything's set, and I am off to the races as far as getting all of my regular databases deployed. So there is command line help options. So if I go ahead and run my help, I can see the handful of options that we have as we go through these. I'm going to touch the important ones and the ones that we use daily throughout this presentation, but you can easily get to the help file. It has a configuration file that is a global config. So let's just take a quick peek at that. So again, everything is bash. These files are just getting sourced. So there's the format that you want your timestamps to be in. There's the name of your deployment's database if you wanted it to be something else. There's things that you can do to get that renamed throughout here. There's verbosity levels. There's confirm flags, default to false. Like I said, by default, we are specifying a Postgres data type. There's allow drop and reload. By default, that's set to false. Nobody would want to accidentally drop and reload a prod database, but in test, things break and go bad all the time, so it'd be really nice to be able to just set that flag to true in test environments, and then it's one button to go ahead and just drop it and bring it back up to current. Some of the base directory stuff that I mentioned, so a lot of options in here. We also specify a run as user, so if you are not the Postgres user, it will gripe and moan at you, which again for our implementation works great. You can unset that variable in your overrides or comment this out here if you're doing it for other things. So a handful of variables throughout here, tried to abstract pretty much everything out. And then, as I mentioned, there is your home directory file that gets sourced and overrides that as well. We catted in our base directory earlier. I'm going to go, well, I'll wait and do that here in a bit. So let's go ahead and actually deploy our first database. So I'll show you guys what we've got here. So DBdeployer -D and the database name, and then a -R is pretty much the simplest implementation. The -R is for report. This database doesn't exist yet. When we run a report, it does ask us, hey, didn't find this database, do you want to go ahead and create it? I can run with a confirm flag and it won't bother asking me that. So it creates my database and then says, here's everything you need to run to get this database to current. And it gives me the actual commands that it does. DBdeployer just calls itself when I say bring me to current. It actually runs a report and then sucks out all of these DBdeployer commands to be able to play through them. So we'll go ahead and deploy this file. If we want to deploy just an individual file, be it something got added and the first ones weren't quite there yet or whatever, we can pick, choose, do whatever we want. It is based, if something's based on another SQL file, obviously it'll break saying dependencies aren't there. But all we're doing is deploying files. It's literally just that. So it goes ahead and deploys that file. If I run my report again, we'll note that the schema file is no longer there. If I change that R to a U, it's going to go through and it's going to deploy every last one of those. So now my report's empty. Pretty simplistic usage. Let's go through here. So rollbacks are something that I kind of went back and forth with some of the other DBAs and sysadmins on. Once you're in production, and we're using this, it's an all additive process. Once something goes up to prod and somebody checks out master, if I want to roll something back, I can't roll it back without affecting somebody who's already checked it out. Master will be in an inconsistent state with them. So once something's been merged to master, at that point, everything is a roll forward. So if I want to roll something back, I'd actually copy that rollback script into a new file and then play that as a new file. But if I'm in a test environment, it hasn't merged to master, nobody else is using it outside of these couple of devs. They know what's going on, they're requesting it roll back. It's all right to go ahead and roll that back. So I'm going to go ahead and roll back, which again, we typically don't do outside of test environments. But I'll go ahead and roll back one of these files here. And if I were to go into our deployments database, as we go through these, I can see every deployment, I can see what user it was deployed as and what user it was deployed by. The difference being, we deployed it by myself, or Vagrant in this case, we deployed it as Postgres, so you kind of get some of that tracking functionality. You can see the status, everything's okay, what file was deployed. all kinds of information. And we can actually see the deployment type. So you'll see here, we've got a rollback. Everything else was deployed as a change. So with the mindset that rollbacks in production would be actually a roll forward with a new file, we don't actually tag it and say, hey, I rolled this back, but I need to step back in the timeline so that I could replay it with a report. So that was a conscious decision that was made. It works in the prod scenario, less so in the test environments. But if I were to go then and roll forward that same file, maybe devs made a change and they want us to roll it back out, they fixed it, it's going to come up and it's going to say, hey, I already found this file deployed. Are you sure you want to do this? So it's got some of those safety checks in it to make sure everything's safe and that you're not going to redeploy a file on a server without confirming it or at least passing in the confirm flag. So I can go ahead and redeploy that. Everything's good. And full screen mode is being friendly. And again, everything is just based on file names. If I wanted to go ahead and touch a new file in our changes directory, new file's there. We'll pretend for now that it has SQL in it. And we'll go ahead and do our sample DB, our report, and it shows up in the report. Update's going to go ahead and do that same thing, play through it. So we just deployed an empty file to my thing here. There is also the ability to deploy things with a skip flag. There's some changes as a DBA that you say, I really want to watch this. I want to go line by line through this and I want to paste it. It's a tough change. So in that instance, maybe you do deploy something manually, but then your deployment stuff's actually out of date with that. So you have to be able to go back and say, hey, don't try to deploy this file again. We need to skip that. So to skip something, we'll go ahead and touch a new file here. And then if I pass that a -K option that you see here, that deploys it and it won't be back in our report again. So that's how I would address a manual deploy of something. And then the drop and reload, again, built for test environments. If I go ahead and do that, at this point, it's going to yell at me and it's going to say, hey, your configuration file has this disallowed. So I can go in either through my override file in my home directory, or I can go into the global file and I can change that to allow that. There are some options for the future that I plan to allow you to disable in the global. You wouldn't want necessarily a developer to override a drop and reload on a prod database and do that. So this is one of those situations where we can make that a little better. But if I just go into my config file here and I paste in my allow drop and reload to override that. So now if I come back in and I pass an X, it's going to say, hey, are you sure you want to do this? Again, I can override that with a -C so it doesn't ask me. I hit my yes, and it goes through, drops everything, and rebuilds it back up to current. So our dev environment is now back to a sound state, and everything looks good. So last but not least, to kind of show you here in the demo of what's going on. Helps if I don't paste Vim in front of it. So everything is logged. The timestamp, I chose to use just a regular actual timestamp instead of a date format. That's in that config file that I showed you there at the top. The database name, what change type, the actual file that's deployed. So it's going to show you if I deployed something that was in an environment file, it's going to give me that file here so I can see exactly what was done. And then it's going to show me all of the output that scrolled by on the screen saved through here. And then it shows me the status OK. This particular file is the one that we deployed a couple of times, so it appends all of that data onto the end of the file. So it gives us all of the tracking that we need and a good way to manage these particular databases. In our environment, like I said, everything is actually done locally on the server. So we have our wrapper script set up to reach out and tell the servers, hey, check out this branch and test, and go ahead and deploy it to all of the test servers. Or when it goes to master, go ahead and deploy out. So that's a wrapper script that we use to communicate with all of these different instances. So that is all I have. Does anyone have any questions?
The description of your talk said that it would be ready with MySQL at the time of release. How's it coming with that?
It is still in dev. I had hoped to have that ready. We don't use MySQL actively at work. I was a MySQL DBA by trade before I joined CoverMyMeds, so it is a hobby time thing. I'm hoping within the next 2 to 3 weeks to have that completed. I do have a branch out on my local. If you're interested in that, I can push that up so that people can kind of see the work in progress or test and play around with it.
Hi. You mentioned you're a Ruby on Rails shop. Ruby on Rails, like Django, provides some support for database migrations.
Mm-hmm.
What was the motivation that you chose to not really build on any of that, but build a more general purpose tool that seems to replace a lot of that functionality that's already there?
So it was a handful of reasons. One, we didn't have visibility. DBAs don't understand what's going to happen when you see what a Rails migration is. It's at a code level, and again, some of the Rails migration stuff's not going to pick the most efficient way to deploy that SQL. So that was one of the factors. We have multiple applications that have the same database. So from a Rails perspective, do you have a parent app? Do you have, maybe a migration a migration application that manages it at the database instead of at the app, where you deploy that and then deploy it? There were a handful of things. Some of the native implementations, and some of this may have been fixed by now, but the implementations that I saw in use at the company early on required the user to be the same. So you had additional permissions where, it's a CRUD app. I don't need to be able to drop users. That'd be a horrible thing to give permissions on. So as we went through some of those, I'm not saying that Rails couldn't address these problems, but as we went through them, it seemed like it'd be just as much work as what we went through, and this is kind of friendly to both sides of things. So with this, everything deploys to PostgreSQL. We can fix some of the issues. It gives us more visibility into what's changing. Rails didn't used to support foreign keys. Well, how many of our stuff that was stood up in test didn't have those? So we can catch that when it's actually in SQL and have a better chance of standing up reproducible environments. And our current path, actually, the developers, they do things through Rails, and I don't know if we've open sourced it yet or not, but we have a thing called CoverMyMigrations. So they run their migrations, and it actually sucks everything out, and then we'll help create the pull request for them with the SQL that they need. So they can still do whatever they want in Rails land, be happy, kick the SQL over, and if we tell them, hey, we've got to refactor this, we can do that, and it's a relatively smooth process. Anybody?
You said you're going to open source it. What license are you going to use?
I believe we use the MIT license on it. And like I said, it is actually already open sourced on our GitHub page. So the CoverMyMigrations is the one I'm kind of iffy. I'm not sure if we've open sourced that one yet or not. All right, well, thank you guys.